Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In the last few videos, we have discussed a lot of questions about AP Physics 1 exam. And in today's video, we will discuss more questions and we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 31 says the figure above shows the net force exerted on an object as a function of the position of the object. The object starts from rest at position x is equal to 0 meters and acquires a speed of 3.0 meters per second after traveling a distance of 0.090 meters. What is the mass of the object? So in this case, it is given to us, we have mass m. So imagine that mass of this object is capital M. We need to find out this mass, and net force is acting on this object. So we can also imagine net force is capital F, and in this case it is given to us object is initially at x is equal to 0 meters, and we apply net force on this object for a distance of x is equal to 0.090 meters, and we need to find out what is mass of this object. So we need to find out mass of this object. So in this case, we need to understand, as net force is acting on the object, this net force will increase the kinetic energy of the object. So simply we can say, in this case, work done by F means work done by net force. This will be equal to change in kinetic energy of the object. That in this case, the initial kinetic energy of the object is equal to 0. So simply we can say this is 1/2 mv square minus, as initial kinetic energy is equal to 0. So simply we can say this one is equal to 0. So in this case, simply we can write down F net time distance t. This is equal to 1/2 mv square, and we need to calculate in this case value of m, and the final speed is given to us. We have value of v, that is equal to 3.0 meters per second. So we have the final speed. Fd is the work done, and we have force on y-axis and position is given to us on x-axis. So area under this line, this area is representing work done. So simply we can say this area is equal to work done. So this is work done. So in this case, area is representing work done, and area in this case is equal to 1/2, because this is a triangle, time force time the base 0.090, and this is equal to 1/2 mv square. So we can write down value of m, value of v, because value of v is given to us, so we can replace with its value. Value of v is given, that is equal to 3 meters per second per second. So we can also consider in this case 1/2 with 1/2. Now simply we need to find out m, so we can write down 3 times 0.090, and this is divided by 3 square. So this is divided by 3 square. So we can cancel this 3 with this. So simply we left with 0.090 divided by 3. So the final answer should be equal to 0.030 kgs. So this is mass of the object. So you can see the beauty of physics, how we have calculated mass of the object by simply looking at motion of the object. So the answer for this question is B. Question 32 says two identical carts are free to move along a straight frictionless track. At time t1, cart x is moving at 2.0 meters per second when it collides and sticks to cart y, which is initially at rest. Which of the following graphs best shows the velocity of cart x before and after the collision. A beautiful question just based on conservation momentum. In order to answer this question, simply we can sketch. First of all, we can imagine this is cart x and this one is moving to the right with initial velocity ux, and its initial velocity is equal to 2.0 meters per second, and cart y is at rest. So this is cart y, this is at rest, and these two carts, they are identical, and after collision these two carts, they stick together. So simply we can draw here, they stick together. Let's say this is x and this one is y. So in this case we need to understand the initial momentum is to the right, so this is equal to 0. As initial momentum is to the right, we can take to the right as positive. So the final momentum also has to be to the right, because in this case there is no net external force acting on the system, so momentum has to be conserved. So these two cars, they have to move to the right. Let's say the velocity is v. Now simply we can use conservation momentum. Initial momentum in this case has to be equal to final momentum. We can also imagine mass of each cart is m, because these are identical carts, so they have the same mass. So this is mass m, this is also mass m. So momentum of first cart we can write down, this is m times 2 plus 0, and final momentum we have m plus m, and they're moving with velocity v, and we can calculate value of v. So from here we can write down v will be equal to 2m divided by 2m. So this is equal to 1 meters per second. So this is velocity of x, and also this is velocity of y. So we have to look only at velocity of cart x before and after. Before, we can write down velocity of cart x before, velocity of cart x ux, this is equal to 2 meters per second, and after collision the velocity of cart x decreases to 1 meters per second, but it is still positive, 1 meter per second, still positive. So the first one is not possible. This is telling us that the speed is not changing, and this is telling us speed decrease but less than 1, I mean decreases by less than 1. So this option is also incorrect. Final velocity has to be 1. This one is correct because this is initial velocity and this is final, and this is 1. So this is our answer. This is incorrect because this is telling us velocity after collision is 0 meters per second. So this is incorrect. So the answer for this question is C. This is how you can approach this type of problems. A beautiful question. If you look at this one carefully, it will help you to understand conservation of momentum.